Hello everybody, and welcome to our video where we're going to continue to work on finding tangents and normals for logarithmic and exponential functions. Okay, and then eventually trigonometric functions as well. So here we have a function y equals x squared times e to the x at x equals 1. The tangent cuts the x and y axes at a and b respectively. Find the coordinates of a and b. So I'm going to just do this. Okay, so our first step is that we need to find the equation of the tangent. So I'm going to use the product rule here. I'm going to take the derivative to find the value of the slope of the tangent when x equals 1. So using the product rule, we get 2x times e to the x plus e to the x times x squared. Plugging in 1, we get 2 times e plus e times 1, and a total of 3e. Then I take the original function, and I'm going to plug in the value 1. I'm going to find the point of contact, which is 1 and e. Okay, and I'm going to write my equation. So the equation of the tangent is y minus e is equal to 3e, which was my slope, times x minus 1. I'm going to simplify and get y equals 3ex minus 2e. Now, so far, that's what we've been doing in this section, but we're going to add a twist to it. If I want to find a, which is the x-intercept, remember at the x-intercept, y equals 0. So I'm going to take my equation of my tangent line and set y equal to 0 and solve for x. If I factor out here, I find out that x could be 2/3. Okay, so if x is 2/3, then this whole equation is equal to 0, and we have our y-intercept. Okay, so the point is 2/3 and 0. When it cuts the y-axis, that's the y-intercept. So we're going to let x equal 0. So I'm going to go back to my equation of the tangent. I'm going to let x equal 0, and I'm going to isolate for y, which I find out that y is negative 2e, which means that my y-intercept is 0 and negative 2e. Another challenging example here, find the equation of the tangent y equals ex at the point where x equals a, and find the equation of the tangent which passes through the origin. So again, same steps, take my derivative, plug in the value that I care about. In this case, they didn't tell me what it is. We just say a, so the slope of the tangent is e to the a. The point is a and f at a, so x is a and y is e to the a. I write my equation, which is y minus e to the a equals e to the a, which was my slope, times x minus a, and I expand and I isolate a little bit for, I pull out a common factor here for e to the a. Now remember, at the origin, the x is 0 and also the y is 0. So I'm going to plug in 0 for y and 0 for x. Oops. Okay, and I'm going to solve my equation here. I'm going to find out that 0 is equal to e to the a times negative a plus 1. So either e to the a equals 0, which is impossible, or negative a plus 1 equals 0, so a equals 1. If I plug that back into my equation, I can find the value. I can sub the 1's in for a, and I get e to the x plus e to the 1, sorry, minus e to the 1 plus e to the 1, so just y equals ex, e times x, not e to the x. Sorry about that. Thank you, and we'll have one last video on tangents and normals with trigonometric functions.